In this video, I'm going to explain about the differences between HTTP and HTTPS. That one letter can make a big difference between how secure a website is, whether others can track your usage, and how safe your submitted username and passwords are. To demonstrate this, I'll be setting up a simple web server on a Raspberry Pi. I'll then show you how you can use Wireshark, a tool that hackers use to sniff the network. With this, you'll see how insecure HTTP is, and how it can be made much safer through adding encryption. I'll be using a Raspberry Pi for the demonstration, but you could follow along with other Linux computers or using a virtual machine if you prefer. So let's get started. I'm going to start by showing a basic install of the Nginx web server, along with a very basic login script. I'll be coming on to how you can secure this later, but in this version it's just going to be basic HTTP, no encryption, and just everything transmitted in plain text. I'm going to start a terminal. I'm going to install the Nginx using sudo apt install Nginx. I'm going to install a few more packages, so just click yes to that. By default, it's set up as a basic web server and it'll serve files out of the default directory, which is /var/www/html. As you can see, there's a file called index.nginx-debian.html in there. We don't need that, so we can just delete that. We'll just use sudo at the moment so that we're using it as root. And we'll replace that with our script. I had to use that as root, but if I change the ownership to my own username, my username here is Stuart, but you change that to whatever you want, then that will set it so that I can write new files to that directory. Alternatively, you'd have to be as root to be able to edit that. I do need to use that using the sudo command, so I'll just add that so it's running as root, change ownership to myself, and now I can update as required. To be able to use PHP files, we need to first install the fastcgi package. So it's sudo apt install php fpm. Going to install a few other packages as well. Just type yes. Once we've installed this, there's a few parameters we just need to tweak to make it a little bit more secure. So I'm just going to add or change a particular entry in that to tell PHP not to try and execute the closest file it can find. If the file can't be found, it should just access the file that we tell it to. So that's in /etc/php, and then the version in which is 7.4. This version, fpm/php.ini. And just looking for cgi.fix path info. Here's the entry just at the bottom of the screen. So I'll just change that to a 0. And that's just going to make it a little bit safer. I've now uploaded a file called index.php to that vast www.html directory. Now this is a very basic script. It's not really useful for anything really. It's literally just going to take a username and password and display that on the screen. You can see there it's called index.php. Now Nginx won't automatically serve index.php files or any .php files, so we need to add this index.php as a default file in the config file. And there you go, there's a comment there that says add index.php to the list if you're using PHP. So we also need to enable PHP CGI functionality just by uncommenting this location section and the entry that says fast CGI pass Unix, and then it's got the Unix socket PHP reference. Save that. We can just test that file using Nginx -t. I've missed the final bracket, so actually go back into it, we can just add that. Yeah, we have to uncomment that closing bracket as well, so close that now. Now we can run the test again and use the reload, and that's reloaded the Nginx web server. Just going to quickly show what that index.php file does. This is a web browser running on another computer, and I've just connected to that, the web server, which is on 192.168.0.165. The file that's on there gives you this login screen, which is just a HTML form. It allows you to insert a username and password. That is passed to the index.php file, but it doesn't actually do anything with it. It just comes back and shows your username, regardless of what your password is. So what it actually does with it, normally, obviously, that would be a back-end login process and things like that, but this is purely for demonstration purposes to show you what you can see using Wireshark. So I'm now going to install Wireshark on the Raspberry Pi that's acting as my web server, and that's going to sniff the network interface and show us the traffic that's going on. This will be installed on the web server. Note that a hacker would be trying to intercept this some other way, perhaps connecting to the switch and trying to intercept it that way, or perhaps found some way of tapping into your connection otherwise. Could be running a router or something similar. I'm just going to install Wireshark. It's in the standard software repository, so I can just use sudo apt install Wireshark. I'm going to install all these packages. This allows you to use a group to be able to run Wireshark instead of running this root. That's probably a good idea to do that so that you don't have to run Wireshark as root. So I'm going to choose yes at this point and install, so that you just need to be in the Wireshark group to be able to run this. So now we can add ourselves to that group, which is done using the usermod command. This is done using sudo usermod -a to append, -g for the group name, and then your own username. And that's added us to that group. I am going to make a change to the web server first, just to disable gzip compression. Now, gzip compression does not add any extra security to a session, but it does make it a little harder to read in Wireshark, so that's why I'm going to turn it off. Also, it needs to be turned off before you use HTTPS, which is what I'm going to come to later. So basically looking for the setting that says gzip on, and we'll just change that to gzip off. The benefit of using this is that it saves on bandwidth by compressing files as they're sent over the network. I just need to restart the server now. I'll just test the config file first and then reload the web server. Now I can go into Wireshark. I'm going to put a filter on this, and see this has a capture filter. Wireshark has two types of filters. This is the capture filter, which reduces the amount of data that's captured. You can also put a display filter, which you can see at the top. If you use the display filter, it still captures all the information but only displays what you filter out. The benefit to using capture filter is it's going to greatly reduce the amount of traffic that you see and saved, so it's going to result in a smaller file. The advantage of using the display filter is you've still got that other information if you need to retrieve that later. So this is now showing the communication between the web server. I've just repeated that session in the browser where you saw a log on, and we can see the GET request. This is loading the initial page just using the slash, which say we set up to return that index.php file. And now this is the response, and as you can see, this is the index.php file being returned, and you can see that it's got the form asking for a username and password. And now we can move down and see the post file, which is the data being passed, and this is where we logged in with the username and password. And lo and behold, in a minute we will see at the bottom is your username and password sent in plain text. Clearly my username, I put test, my password was test1 password 2 as one word. The spacing in there is just for convenience trying to read this, but basically the real danger is that the password was just sent plain text. Anybody who could physically get onto that network and monitor the traffic in this way can see your password being sent to and from, and obviously that's very dangerous. You just need to sniff on the network, find the password, and then you can log in as that person. And this is why we need encryption. This is a real big thing. Imagine you entered your credit card details. It basically allows somebody using a sniffer to capture those details and then be able to use them for malicious purposes. And that's why we need encryption on our web traffic. Before they can do that though, they do need to have a point of monitoring the network. For instance, I've installed Wireshark on the server itself, but it doesn't need to be on the server. It could be on any intermediate point between you and that server. A particular example would be that you come across a public Wi-Fi network, connect to that, and it's actually a hacker's network that's allowing you to connect to the internet but monitoring all that traffic at the same time. So you do need to be careful about what you do on public networks, and also be careful that you're always on an encrypted site when giving away or using personal information, putting that in a website. Don't do that on something that just uses HTTP. So the solution is to encrypt the data. Encrypt the data between your laptop or your web browser that you're using and the end server. And that's done by using a protocol known as HTTPS. HTTPS is a way of encrypting the information so that even if somebody intercepts the traffic, they cannot understand it. This is based on the use of encryption keys that keep the message secret. You also need certificates which are used to prove who you are. The technology behind HTTPS is called Secure Sockets Layer, abbreviated to SSL. Actually, usually it's normally based on TLS, Transport Layer Security, which is the newer version of SSL. And sometimes this is referred to as SSL/TLS. Or it's often that people just refer to it as SSL, regardless of whether it's SSL or TLS. And this may also depend on the browser and web server, as they can negotiate which version of a encryption key to use. For example, when TLS was released, then the server may have been upgraded, but the client not. So in that case, they may have negotiated to use an SSL key instead. If all that sounds confusing, then don't worry. You can just think of SSL and TLS as being the same thing. TLS is more secure, but it's effectively just an updated version of SSL. If you're running a production website, then you should get official certificates registered through a trusted certificate authority. This will mean that another organisation has said that you are who you claim to be. But for this example, I'll be using a local web server, just used for a maker project. I'll be creating a self-signed certificate, which will result in a warning in your browser. The process is similar as if you're using an official certificate, but there may be some extra steps required, which your certificate issuer should explain. One example is Let's Encrypt, which provides free certificates which can be installed using their tool certbot. Note that Let's Encrypt is not the same as using a commercial certificate authority. They won't require you to prove who you are, and your certificate will not have the same trust relationship as if you go to a commercial certificate provider. The library used for this is OpenSSL, and we'll use the OpenSSL tool to create the encryption and certificates. First we can create the encryption keys and certificates, which are going to be used to secure the session. I'm going to copy and paste this. I'll put this in on my website. And this is using sudo to run as root, and it's the OpenSSL command. This sets various things about the encryption, such as it will expire in 365 days using an RSA 2048-bit key, and this is where the key will be output, and this is where the certificate will be output to. So it's going to ask some things about the certificate. So use UK. The next one, so it's asking about the name of the server. Normally that would be FQDN, fully qualified domain name, so that's such as www.penguintutor.com or something like that. In this case, I'm going to use the IP address of the server because it doesn't have a fully qualified domain name. And that's created the certificate. I'm also going to create a Diffie-Hellman group. This is used for perfect forward secrecy. Essentially, this is a way of protecting past communications if the encryption key is broken in the future. So if somebody is able to capture the data now, and then your key is broken in the future, it means they can't decrypt your old messages. Uses the OpenSSL command as well, but the DH parameter -out/etc. I'll just put it in the same certs directory. And so it says this is going to take a long time, so it's going to be not quite as quick as the previous keys. Okay, so that's completed now, and now we can update the Nginx web server to use these. Going to make the changes in the sites file. If I go to Nginx, we look, there's two folders. One's called Sites Available and one's called Sites Enabled. These will show the same at the moment. And so Sites Available is where you store all the different kinds of sites that you want, because a single web server can serve up multiple websites. And then when you enable them, you normally put a link to Sites Enabled. And as you can see, that's the same one. We'll just put a -L on that. You'll see that this is a link rather than the actual file. Now you could edit either file. Because of that link, you'll just be editing the same file regardless. But it's actually the one that's in Sites Available that's the standard file. You may want to take a backup of this beforehand. So in fact, let's do that. Let's go into CD to the Sites Available, and we'll just CP default to, because it's not copied into enabled, then it won't be enabled. It's just there as a backup basically. So you need to edit this as root, so we use the sudo. Let's get rid of the port 80 entries at the moment. So this is standard web server that's been running so far, which is on port 80. We will later on redirect those. That will be a bit later on in the file. So we'll come on to that in a bit. I'm going to enable these listen. So we're going to listen on port 443, which is what's used for SSL. Tells us about disabling gzip. We've already done that, but if you hadn't, then you would have to do that as well. And there's some information on creating a secure configuration. I'm going to be just putting a few basic settings on there. You may want to look at further ways of securing it further. I'm going to change that server name to be the IP address. Again, you would normally use the website name, fully qualified domain name. And then I'm going to add some lines of effect. Just realised. That's fine, we'll leave those there. Then at the bottom of this server section, which is here, I'm going to put in the certificates. So these are the certificates we're using. So you've got the certificate key, and that dhparam file that we created as well. I'm also going to add some information about the protocols we want to use. Put those in here. So there are various different settings that you could use. And there's just a few of them. So that's the SSL part done. I'm going to just add one more section. Right at the bottom, I'm going to add another server entry, and this is going to redirect anything coming in on port 80, the standard HTTP, to port 443, the HTTPS server. Again, I'm going to copy and paste this, so I'll include the code on my website. Again, see the description for details of that. So this is just saying that if the host matches this IP address and we're listening on port 80, then return 301 redirect to go to the HTTPS version. That's it created. Just clear. I'm going to run the test to see if there's any configuration parameters. Doesn't seem to like my SSLDH param, so let's go and have a look at that. 976. I've just missed the semicolon off the end. I can do that and try testing again. Yep, it's okay. Test is successful. So now we can reload. Because of the changes, I'm going to do a full restart of the server rather than just a reload. So I'll do that using a system control restart. I can just check the status on that, make sure it started correctly. Yeah, looks like it. So I've switched to my laptop now. So I'm on a different computer to the Raspberry Pi that's hosting the web server. I can now put in the address, and as you see, it's come up with a scary message. This is because we've got a self-signed certificate. So what you can see is that although I only typed in without the HTTPS, it's gone to the HTTPS site, but it's put a strike through. Your connection is not private. Be careful what information you give, basically. And it shows that the security certificate is not trusted, and that's because it's a self-signed certificate. So if you ever get this on a normal website, then stop what you're doing and verify before you proceed. But because this is a self-signed certificate, I was expecting this, so it's safe to carry on. And there's more information on here, and it says that it's basically not being signed by anybody. The issuer is just myself. So we can click proceed. As you see, we've got the website before. We can put in a username, password, and it works in the same way as it did before. And now we can take a look at Wireshark and see what we can see using that. So I'm back on the Raspberry Pi now. I'm going to start Wireshark again. I do need to change my filter a little this time because I want to be able to watch both port 80 and port 443, HTTP and HTTPS. Port 80 or port 443. So I can set that going. Oops. So capturing from Ethernet 0, port 18443. So if I now go on to the browser and this first bit is just loaded the first page. I'm going to put my username in now and submit a password. Right, so we can now take a look through the traffic. So there's quite a bit more traffic than before, and see what it's found. So we can see these are some TCP handshakes. So here's the handshake, and during the handshake it's basically turned around and said you're not accepted on port 80, you need to go to port 443 instead. So then it started the handshake again with port 443, and we've got the client hello. You can see it's HTTP 1.1, but then everything else is encrypted. So server hello, and again a encrypted handshake. You can't even see which pages they're asking for. Did get a certificate unknown here, and then remember we accepted that and then carried on. So sends the request again. So this is the request for the web page. And basically none of this data is of any use to us. The application data, you can't make out what the page said, and you certainly can't see any usernames or passwords. All you see is this encryption related traffic, and then this is finishing the handshake off. Yeah, so as you can see, it's all nice and secure now, and this is exactly what we want. We need to make sure that any data we send, if somebody is sniffing the network, they basically just get encrypted data. They cannot see what pages you've requested, what the information on that page was, and they definitely can't see your username or password as it was exchanged. But as you can see, I'll bring up the browser. This is what we see, and it's allowed us to log in. So as you can see on this video, basically looked at using HTTP, and as you can clearly see, you can use a tool such as Wireshark, monitor the network, and you can see exactly what is going on between the server and the client. You can see what web pages were accessed, you could see the data that was going backwards and forwards, and crucially you could see the username and password. And that would apply if you put anything into HTTP. That could include credit card details, etc. Really, it's not secure. You could still use it for just browsing normal websites, as long as you don't mind people being able to see your history, but you definitely won't want to use it for passing any secure information. And then you've seen how we can improve our security by reconfiguring our web server to use TLS/SSL security, use their encryption, encrypts the data so that you cannot read it, you cannot understand it. You can capture it, but unless you know the encryption keys, which are kept securely on the server, you can't understand what the conversation's saying. And obviously that is much more important from a security point of view. That is how banks protect your information, how your information is protected when you put in your credit card information. It's really important that you always check that you do get these secure padlocks on your web browser when you're going to a website and you're entering personal information like that. As we showed here, we used a self-signed certificate. That means the web browser is not able to verify that as a valid certificate, and that's why we got a warning message. You could use a free service like Let's Encrypt, or you could use a commercial service which will give you a proper signed certificate to say that they have proved that it is you that is running that website. So I hope this has been useful. If it has, please give it a like. If you've found anything new, please leave a comment. Let me know what you think of it. If you've not already subscribed, please do so and click the notification icon to get notified of when I create future videos. I'll be looking at other security related aspects on this channel, both hands-on practical like this demonstration with Wireshark, but also some of the theory as well. So if you're interested in learning more about cybersecurity, then please do subscribe. Thank you for watching. I look forward to seeing you on a future video.